Welcome back to this lesson where we're talking about thinking like physicists, thinking physics. It's so exciting. And you know what? Apart from the first steps, it's all about engaging critical thought. And it's about encouraging questioning wherever you are. Not just when you're in the exam, when you're walking down the street, trying to relate what you've read in your textbook to what you're seeing in the real world. And so when we think physics, there are some critical thinking steps that we go through. To make our information real, we collect data. That's mainly through observation and experiment, and then we analyze or we organize the data. And organizing the data helps us ask more questions. And so in those questions, we try and form some ideas about what are the relationships that exist between variables or quantities. And out of that, relationships translate into formula or equations. And we can then perform those calculations and evaluate our answers. And that's very important. When you are checking and evaluating your answer, you've got to say, does this make sense? What would happen if I changed an input variable? Would it really make sense that as you increase that variable, another dependent variable is going to increase or decrease, or whatever the case might be? You've got to check, is this making sense? And of course, in your exam, make sure that you've answered every question with an SI unit, and if it's a vector quantity, add the direction to it. So one of the ways to improve your critical thinking and practice getting things into the right order is to look at some multiple choice questions. Multiple choice questions are there in the exam, but they are very good for practicing to check that you know what's going on and you can think like a physicist. So what do we mean about multiple choice questions? What's some of the strategies we've got to do? The first thing is obviously to read the question. I don't always read the options. I just read the given information, and I then try and not the options. Sometimes you have to read the options because that's the only way to make sense of it. I also try and identify the topics. There are times when I've looked at the topic, I look carefully at the option and then read the question. So it just depends in terms of scanning. Option first, and then the info that is given, and then you try and answer it. Very important. You should try and calculate an answer with a multiple choice question. Don't guess. You know, you're wasting your time if you just go ABC, throw the dice. Not going to help you. If you think carefully and you do a calculation, you can be much better confident of what's going on. Now, in terms of confidence, I also want to say to you that I never encourage learners to answer multiple choice questions at the beginning of an exam because they jump from topic to topic. And so it's very important that you read the questions, let your subconscious take note of what's there, and then in your reading time you can do that, and then leave it. Answer the question that you're most familiar with first, and then allocate some time. You only need about 20 minutes, 15 to 20 minutes at the end of the exam, where you're going to do all the multiple choice questions. And by that stage, your brain is triggering and it remembers what mechanics is, what electrostatics is, what circuits are. It's made the connection. And it's also been thinking in the background about all those multiple choice questions. So that's my strategy. One of the other things you can do is always try and eliminate incorrect errors if you're not sure. And we'll show you some examples. So in this particular section, what I want to do is I want to look at a few questions that are related to mechanics and also to electrostatics. And we're going to try and see a pattern here. It's pointless just learning the answer. What we want to do is to promote the skills and the thinking of the answer. So follow me as we go through these questions. So it tells me in the diagram below, They represent 4 vectors, Q, R, S, and T. Which one of the vectors is the resultant of the other 3 vectors? Now, what I hope you can see is just by reading that introduction, I don't need to look at A, B, C, and D at the moment. I can simply look at the diagram and make a decision. And so when we're dealing with vectors, we need to understand that vector addition is always done head, that's the head of the vector, and that's the tail. So we always add vectors head to tail, and you could have 3 or more vectors added head to tail, doesn't matter. And the resultant will be the one that starts at the beginning and ends at the end. It will start tail to tail and end head to head. So I'm going to apply that reasoning over here, and I'm going to say, if I do this one, I'm going head to tail, then I'm going there, that's head to tail, then I'm going back. So those 3 vectors are in order, and that tells me that my resultant vector is going to be the one that starts at where the 2 tails are and ends where the 2 heads are. This is going to be the resultant. So R for resultant. And so I can, with confidence, recognize that B would be the correct option. So please don't panic, but try and do some thinking and calculation about what the topic is. It's very important as you scan through a multiple choice question, you identify the topic. And so the next question talks about which one of the forces, so we're dealing with Newton's laws, cannot be equal to 0. So we're looking at for something that cannot be equal to 0. It's not equal to 0. So we've got the normal force, the frictional force, the gravitational force, and the applied force. So in this case, I had to read the options. And so I say to myself, what's the normal force? Well, the normal force is the force of a surface pushing up on an object. The frictional force is the force of the surface that is acting in the opposite direction to the applied force. So if we had a frictionless surface, then we can make that 0. So this one can be 0, so we are excluding it. Can the applied force be 0? Yes, we can say we're not going to exert any force on this object, so let's just make that 0. So we're left with 2 now to look at. We're left at either the normal force or the gravitational force. So being here on Earth, can the gravitational force ever be 0? Well, if an object has mass, and the Earth we know has mass, there will always be a gravitational force. The universal law of gravity says that there is a force of attraction between any objects that have mass. So it is not possible for there to be no gravitational force. Whereas it is possible for the normal force to be 0. This one can be 0 because we could have a situation where an object is resting on a surface, it has a gravitational force, but there is at the same time an upward force that is applied to this. And so the surface isn't pulling up, but the upward force and that object is just suspended above the surface. Then the normal force would be 0. So I hope you can see we've thought it through and we've come to a conclusion that the correct answer is C. Let's move on to the next one. We're told here, which one of the following graphs represent the relationship between the gravitational force F and 2 objects and the distance between them? So immediately I see this. I've got force, the mass of 2 objects, and the distance between them. So they're not saying mass here. And if we looked at the graph, we'll see the graph is force and it's related to the distance. So immediately I'm starting to say, well, what's the formula? What's the law? And those are the critical questions I'm asking. And so I need to recognize that force is directly proportional to the product of the mass, and force is directly proportional to the square of the distance between the objects. And I can write D like that, or I can write 1 over r squared. So if I'm looking at a graph, I would expect if we had f and we had 1 over r squared here, those are directly proportional. And what's directly proportional? It's going to be a straight line through the graph. So just by looking at the relationship, looking at the formula for the gravitational law, I can come up with what I think the graph would be before I've even looked at it. And so what do you see here? Well, there was force in newtons, and there is 1 over r squared. And I don't even have to worry. I can see straight away, this is my answer that I've calculated. It can't be constant force. The force changes, so it can't be that one. The force changes, I eliminate it. The force here decreases with that's not true, because as the distance gets, 1 over r gets bigger, the force isn't getting smaller. And it's not that either. So we can eliminate those and say the answer is there. So the final question that I want us to look at is one which is a little bit more complex, that has two things. When you get these, please read the question carefully, and you'll see you've got to make a decision about positive and negative and so on. But it's about processing the information. Read the information carefully and then make a choice that's going to be the correct choice in terms of P being the positive object and Q being the negative object, because charge is transferred from P to Q. So guys, please remember that you can do this. You've just got to practice, and you've got to think physics all the time. Now that we've looked at different types of multiple choice questions, let's take a quick break, and we'll be back to look at some more questions on mechanics and electrostatics and electricity right after the break.